what is unique about this system is the signal amplitude is checked, and there is another reflected signal. This combination of the thing is checked, and you get a judgment out of the signal sensed from the track. And it's all. Thank you for this opportunity.
Thank you, Mr. Pramod, for introducing us to another method of detecting whale fracture and whale crack. There have been many presentations on this topic outlining different methods. This topic is attaining a very, very important role in our safety scenario. So thank you so much. You have something you want to say?
No, sir.
The questions may be addressed to the author, sent to us. Paucity of time is there, so I will not be able to request the authors to answer your questions. But you remember which questions you have sent and catch hold of the authors either during lunch or after lunch. The next speaker is Mr. Tanuj Junjunwala, CEO of Planis Technology, Chennai. And his topic of presentation is using remotely operated vehicles for underwater inspection of bridges. Mr. Tanuj Junjunwala.
Thank you so much for having us here. So I'm Tanuj Junjunwala. So today I'll introduce you a technology which is a drone. So over the day I've been part of 2 seminars where aerial drones have been used. So I'll be talking about something called underwater drones. So these are remotely operated vehicles that we have developed over the last 7 years. And these are typically for underwater robotic inspection and survey solutions. In interest of time, I'll be a little quick about this. So overall, bridge substructures require regulatory requirements for inspections for these. And also aging infrastructure plays a very important role. These inspections are done to avoid any catastrophic failures of any bridges. Currently, the methods done by these inspection methods are manually done, like say by divers. And these have limitations when they come to depths they can go to, the endurance they have, the carrying capacity, and the data captured is non-repeatable. It's not that very steady, and they cannot really pinpoint where the problem is. And overall, safety is also an important concern here. So what does a robot do? So the robot is deployed in the water. There's a control station where all the data comes back live. All the bridge engineers and the ROV pilot can see it live. Now the advantages of these systems are, it's a robotic technology, so it's an extremely steady data capture. We can tag the defect with the depth and in which phase of the pier we're seeing it. There's no risk to human life. We can do about 8 to 10 hours a day continuous operation, and we can go up to 200 to 300 meters of depth. So this is broadly how it works. So from a boat or a fixed location, you launch the vehicle. You have various photographs there showing how it's set up. Once it's deployed, the bridge engineers see live what's happening here. There's no risk to any humans in this complete operation. And you get live, extremely live visual data coming back. And the bridge engineers can operate and tell, go left, go right, this is what I want to see in detail, and so on. So I'll just move to the videos here. And I'll talk more about the technology like that. So this is the first one we've built. So the video is shown in a swimming pool to make, just to show how the ROV works. So you have onboard propulsion, so we can go in all directions possible. It's deployed by a 2-member group. Sorry for that. So it's deployed by a 2-member crew. All data comes back live, and it is electrically, it is powered by external generator, and it has lights, cameras, and various sensors on board. We can also do various kinds of cleaning on it. So this is a cavitation cleaner mounted. It is similar to a water jet cleaning, but it's much more, the pressure requirement is not very high, and you can expose the complete material and remove soft to medium biofouling growth. So there we are demonstrating cleaning of corrosion on a steel plate. So a lot of times the rivers have a lot of turbid water in it. So we've devised a clear box technology that allows, even in turbid waters, to see through clear water and get data. So this is captured in a project we did for Southern Railways, and we were able to gather good quality, high definition videos, even in turbid waters. And after this, we also do a lot of image processing to get more detailed images out of that. So we've done about 3 projects for Southern Railways, and we're doing 2 projects for Southern Railways and 1 for Northern Railways, and we have 2 for RVNL lined up. So just to give an example, so for Southern Railways, we inspected about 16 pairs. This is how we do our reporting. A separate tab gives calls about the defects, and so this identifies in which phase of which pair, at what depth the defect is located. And on clicking that, you only get a video of that defect. This kind of platform is interactive and very useful to the top management to overall just know what are the problems and address the same. Thank you so much. We have a stall here, stall number 19, where we also are demonstrating the robot itself, and we'll be happy to come around and see it. Thank you so much.
Thank you, Mr. Kanu Junjunwala, for introducing us to a new and latest technology on the subject. Now I call upon Mr. Abhishek Pandey, Business Development Manager, Hexagon India, for his presentation on subsurface mapping and detection system. Mr. Abhishek Pandey.
Good afternoon, everyone. Thank you, one and all. Thanks for providing this opportunity to present what we can support. I was collecting data for this particular presentation, and I was amazed to see that as we, Indian Railways, we are covering more than 120,000 kilometers, means 1,20,000 kilometers, with 114,000 bridges. It's amazing. And I was, of course, amazed to listen that news that the highest bridge today is 7 times higher than the highest pillar we do have. It's amazing. And thanks to everybody who's offering the technology, driving us more toward the technology, more toward betterment in our railways to serve our country. In addition to this, what I can offer, what we can as Hexagon India, we can offer, we are of course building the rail tracks, we are building the bridges, we are building the tunnels. Then what? Certainly, we need to maintain the health of our assets. So being in Hexagon Technology, what we offer, we do have safe rail system. We do have safe rail system, we do have tunnel monitoring, we do have bridge monitorings, and certainly we do have the landslide monitoring, the bridges or the rail routes on our hills. Because of the time, of course, I'll just wind up. Firstly, what we do in track monitoring. Certainly, it's blast monitoring. We monitor the health of blast, we monitor where the blast is growing, where the water is getting with the speed, as our users were mentioning, the speed requirement is 160 kilometers. We do have a capability of move our system at the speed of 300 kilometers. That means faster, but certainly it depends the track we are being offered. And somebody was, of course, mentioning that we need a videography or the video monitoring of the tracks while doing all these things. We do have that capability. We'll be providing the video footage, we'll be providing the data, we'll be providing the 3 surfaces of blast. We do have 3, not unlike Austria, they do have 2. We do have 3 surfaces of blast, and of course we can provide those. As of now, our systems are working in 18 different countries globally. Coming to next thing, the tunnel monitoring. We do have a capability to monitor the health of tunnel, the corrosion inside the tunnel, the cracks inside the tunnel, so honey loops, tunnel rips, water infiltrations. This is a report which tells us the different positions of the tunnel, the rebars position, the depressions. Just running fast. I believe it's fine. So you can see the difference between the concrete slab and the rock bed. We can monitor these things. Now coming to the bridge monitoring. See, we do have a system which will tell you that how much load, excuse me, it's not working. Not on the slide. So of course the bridge monitoring system or health of the bridge, this particular system will tell you the deflation on bridge, on the load and rest position. So in this particular it is telling us the deflection within 3 mm. So we can monitor sub mm deflections. And of course we can have the positioning of that particular point and we can deploy the maintenance part. Position in the sense of coordinates. Shape, real-time monitoring, deformation, particular structure, of course, with the blocks, names, and position of the structures, with sub mm accuracy, that is 0.1 mm, we can go ahead. This is a report, one of the example of the report where we have measured displacement report at one particular point and how much it is displacing. This is landslide monitoring for our hilly areas where we are of course putting up or planning to put the rail line or existing one. So we can monitor from a distance of 4 kilometers. If we don't have an SS, we can monitor from a distance of 4 kilometers. We can cover a span of 4 kilometers with that particular machine, and again the accuracy is sub-centimeters. And real-time monitoring. So we do have 2 monitors in this particularly. When one is a real-time we can see, and another is a data, of course, for a record purpose. Thank you.
Thank you, Mr. Abhishek Pandey. Now I call upon Mr. Kasturi Srinivas from Bentley, India, and his presentation will be on going digital, planning to performance. Mr. Kasturi Srinivas.
Thank you, sir. Good afternoon, everyone. Okay, thank you. So, Bentley's mission is to provide innovative software and services for enterprises and professionals who design, build, and operate world's infrastructure. That's actually our mission statement. We are an infrastructure software company. Without taking much ado, what we have actually for rail as an offering, we do have solutions right from planning to the performance stage. The entire life cycle we actually address, right from conceptual design to detailed design to the asset performance side. This whole technologies are actually underpinned by an environment called a connected data environment. Essentially, if I define it, it's basically a digital place where a coordinated set of processes supported by technology that adds value through creating, managing, and sharing the properties of an asset throughout a life cycle. So why I'm rating this out, because especially in large infrastructure projects, there are multiple disciplines of engineering gets involved at the time of construction as well as the time of operation and maintenance as well. So I'm going to give you an example here where we recently deployed for Nagpur Metro, which is now being extended for Pune as well. What we call a connected data environment, where there are standards available, called publicly available standards, where you can define the information management strategy for project delivery and as well as asset strategy as well. So we kind of localized that to the local requirements, and then where essentially what we did was that we brought around 30 odd disciplines of engineering together. There are about 20 odd consultants and around 15 odd contractors, and then a consortium companies, all working together in a manner where it is actually giving them the ability to create insight and visibility of the project, and also look at how the documentation is actually happening, the workflows, and everything is actually being worked upon in a single environment. It's actually a long presentation. We have a booth. I can cover a little more in detail to understand it a bit more. Essentially, what's actually happening is that since, as I said, many disciplines of engineering collaborating together, so the obvious information is being exchanged from one contractor to contractor, or one discipline to other discipline, so that they're able to interface better and coordinate better, collaborate better, so that the constructability and also the the improvement in terms of productivity of the project actually happening. This is a brief definition of the connected data environment, which is basically a baseline for a large infrastructure projects where we can actually manage the information. So if we can just go a little bit more in detail. In fact, Professor Jain talked about the digital context in terms of the reality modeling, where drone-based surveying is actually taking a lot of impetus. Here is an example where we actually, with the help of the Northern Railway, we did a POC for New Delhi railway station, where we took the drone-based flying and then we took some images around and then built in a 3D model based on photogrammetry, and then it was done basically to look at the assessment of the encroachments and perhaps for extending the area planning, and as well as even to correct your yard layout going forward. So one example I will mention about it. There's also a lot of track interest is there in terms of the maintenance work, and I thought I'll mention a little bit more in detail, where we have a comprehensive solution in terms of whether it's for open lines or construction divisions. You can do for new lines as well as in any freight construction as well, doubling projects, tripling. I think more so, I think I would stress upon the amount of accidents and things like that are happening. There are a lot of impetus is being given in terms of improving the yard layouts and remodeling remodeling of these two yards as well. Actually, that's where I think the software solution really helps people to accurately come up with a design which can be executed on the ground. So in terms of again, the basic will remain in terms of the require a survey data, which can come from many sources. They can do alignment design, remodeling, curve realignment. Some of those capabilities, quantity calculation become a part of the capabilities. Again, if I stress upon a bit more in terms of we do have Indian turnouts being properly configured. We use this interline method calculations, so which means that we can design any complex yard layouts, pretty much effectively and easily. And there's another example which we talked about earlier in the discussions. Track realignment is something which is an important one, and we're currently, helping Amberg, to build a design, calculations behind the scenes so that they can actually go and tap it back. And it has got excellent tools in terms of the managing the obligated points so that you can actually define the sluice effectively so that you can come up with a better realigned track so that you can actually come up with a better alignment basically. Now, I'm skipping some of those things, perhaps you want to understand more. We have a booth, probably, we can cover that more in detail. I think one point I definitely would like to stress upon, like, we heard about the track management system in the earlier part of sessions. We do have a similar system which we actually developed for network rail and which is actually under implementation. But I think the way we see the current track management system being deployed in Indian Railways is an excellent one. We definitely see an opportunity to dovetail the tools which we have in terms of helping the engineers to effectively manage the track and prioritize the maintenance basically. Another one example, the prediction modeling is another one where you can prioritize the maintenance and also look for where to maintain, when to maintain as well. There's another one which I would take 10 more seconds, where we can do a excellent inspection management tools where we can look at your bridge locations and then using a mobile device, you can survey it and then effectively push it back on the server so you can prioritize your bridge maintenance as well. So with this, actually, we can come and visit our stall if you want to understand more about it. Thank you so much.
Thank you, Mr. Srinivas. Now I call upon Mr. Amit Sharma. Mr. Amit Sharma, Director and Founder, Matrix Geo Solutions, and his topic of presentation is Modern Aerial Survey Technology Using Drone for Indian Railways. I find that the drone is dominating the presentations and the discussions in this seminar. So over to one more presentation on drone. Mr. Amit Sharma.
Namaskar everyone. So I represent a company, Matrix Geo Solution, and we are a geospatial and engineering service organization. We have 20 years of experience working in for various sectors, including railways. We have global experience. So here I am talking about drone-based modern survey technology and additional technology. You know that it is being done through total station and digital auto level. That is having a challenge of because it is time consuming. It is quality depends upon the field technician and difficult in inaccessible areas. There are many challenges in open line and under construction railway projects where modern survey technology can help in making the better engineering decision making. So the modern survey technology works on a principle of remote sensing, and we use like photogrammetry, LiDAR, sonar and radar for different remote sensing purposes. Drone-based photogrammetry works on the principle of photogrammetry. I think every engineer knows about this. This works on photogrammetry is the science of making measurement using photographs. And that can be, there you can use the drone-based photograph, manned aircraft-based photographs or satellite-based photographs. But from satellite, you have the limitation of resolution. However, it can be used for PET and DFR kind of surveys, which we did for DFC, Ahmedabad, Mumbai, Delhi, Chandigarh, Amritsar, many areas. But then it comes to drone, where resolution can be controlled. That is in your hand, and you can that can be controlled based on the flying height and resolution of the cameras. And accurate digital topographical maps elevation models and high resolution ortho images can be created, and accuracy of less than 5 centimeter can be achieved, which we have actually achieved in some of the many of our projects which we did for railways. So these are basic about the drones. I will not go in the details because many of the people have already discussed about it. These are the processing platform which we use for getting a very high accuracy results for engineering support. This is one of the example of the video where a drone is flying. These drones are fully automatic drones. We can just feed all the latitude and longitude of our alignment and just press a button and it will go automatically and start capturing the data. So once, right now you can see the drone has gone.